Hi students, a very good evening. Welcome to the session Score Booster uh, conducting by our AS Engineering Academy. Students, myself, Vamsi Krishna, faculty in CSC department in our AS Engineering Academy. And in today's session, I am going to discuss multiple selected questions, MSQ questions, and NAT questions from our subject like artificial intelligence. So let's move on to the session. Let's go through the question. So here we have different statements. Take a minute, go through the question and try to give responses. My dear, here we have different statements, and all these statements are talking about agents concept. A simple reflex agent selects actions based only on the current percept and does not use any internal states. So, what is the current available information from that only simple reflex agent acts? That is the first statement. So, uh, second statement is the model based agent maintains internal representation of the environment to handle partial observability. Yes, in model-based agent, whatever may be the information is available, it can take individual decision by from available data, even it is partial also, right? Yeah, I can say the first statement S1 is true and the second statement S2 is also true. S1 is just like a simple reflex agent, it is just like a thermostat. Uh, when the temperature is in low, it can increases. When the temperature is high, just by taking the operation, it can maintain the required threshold value. Yes, this is a correct statement you can say. S1 is correct statement and S2 is also correct statement. And if you take S3, the goal-based agent always chooses actions that actions maximizes a numerical performance. My dear, the numerical performance measure, the numerical values, it is taken by utility based agent, right? It is not like a goal based agent. The goal based agent is specifically designed for a task. Let's say when you are playing some chess game, the objective of that agent is it simply checkmate the opponent. It can take you to its objective is checkmate or stalemate the opponent. So that situations it can go for. It don't like which action should give you more happiness or something else. It's not done by goal based agent, isn't it? So I can say the statement S3 is false. Coming to S4, a utility based agent can compare different goal states and chooses with the highest utility. Yeah, which move can give you more happiness? What really world likes? In that situation, it can take that action only that was done by utility based agent. I can say the statement S4 is true. And coming to S5, a learning agent improves its performance over the time by modifying its behavior based on the experience. Based on the experience. Yes, my dear, when we discussing about learning agent, uh, I discussed some practical example like just like a mail. So in our Gmail, which can understand which mails are really important to you and which mails we are going to push into the trash box. So it can understand which for which mails you are giving more importance. So the learning agent cannot get the things in overnight. So just by observing, by changing the behavior, it can improve its performance. That statement is really true. S5. And coming to S6, in multi-agent system, agents may have conflicting or cooperative the objectives. Yes, multi-agent in the sense, definitely different agents can work. Sometimes the agent works for the common goal, just like in cooperative manner. Sometimes their objective can be different, just they works like opponents. But in both cases, we can call them as a multi-agent system. Yes, the statement S6 is also true. In the classroom we discussed some robots are assigning the cars, so the interior part and exterior part are assembling by different robots. So multi agent we have discussed there. The statement S6 we can say it's true. And coming to the statement S7, the hierarchical agent decomposes into subtasks and handle the different levels of abstraction. Yes, my dear, if you remember hierarchical, what we have taken layer 1, layer 2, layer 3, layer 4, or something like layer n, right? So from layer 1, the simple reflex agent available, let us say, it can complete the task, it can complete its subtask, and it can forward that output to the next layer. So layer 2 can take it, layer 3 can take it, and finally from layer n minus 1 to layer n also you can take, and different agents are available. Yes, the hierarchical agent decomposes into subtask in different levels of abstraction. My dear, the statements S1, S2, all the statements are true except S3. So the examiner can give simply some set of statements and he can ask S1, S2, S3 are true, or S1, S4, S5 are true. He can frame a different question, right? That is my answer to this. Any doubt from your side? If you want to express in the chat, you can express. Meanwhile, let us see this question. Go through this question. Yeah, which of the following statements are true about 8 queen problem? So it's 8 queen problem, not like 8 puzzle problem. So in this 8 queen problem, we have taken different statements like this. The problem can be modeled as a constraint satisfaction problem, CSP. The branching factor of state space decreases as more queens are placed. Yeah, if you take more queens, definitely the branching factor is going to be decreased. And depth first search without backtracking is guaranteed to a solution. My dear, DFS approach, we are not going to take here. Option C is not at all correct. And state space contains illegal states in which queens attacked each other. Queens attack each other in the sense, what do you say? If two queens are in the same row, when two queens are in the same column, even any two queens are in same diagonal cross also. In all these cases, in gaming problem, we can use it as attack. So the statement D is also true. If one queen is placed per a row, the maximum depth of the search tree is 8. Yes, it's a 8 queen problem. You can get a 8 by 8 square grid like. So the maximum depth can be 8, it's true. And using symmetry reduction, we can reduce the number of distinct solutions explored. Yes, my dear, this is also true statements. By using symmetry, the same pattern way, how the pattern A is divided into half. First half is available and the second half is also available in the same way. By something like A, uh, the patterns can be reducted and we can take that problems as something in the same pattern. Yes, we can take the statements, all statements are true except the option C, right? And go through this question. Yeah, which of the following statements are true about water jug problem? The initial state of the problem is 0, 0. Yes, 0, 0. It's just like a tuple x comma y. Y indicates the amount of water available in 4-gallon jug, and y represents the amount of water available in 3-gallon jug. XY, that is the consideration. The initial state is 0, 0. Yes, it is true. And the second statement, the goal state can be represented by 2 comma y, where y belongs to, y can be 0 or 1 or 2 or 3, something like this, right? 0, 1, 2, 3. Next, coming to this area, uh, the problem can be solved. Uh, the problem can be solved by BFS to guarantee the solution. Yes, what is a BFS approach in breadth first search? As you are going level 0, level 1, level 2, in the same pattern, in water jug problem also, you will filling the water into one possible way. X can be 4, Y can be 3. We can go level by level approach only. Yes, you can say the statement C is also true. And coming to option D, the total number of possible states in the final state and equals to 20. When you are taking the capacity of a 4-gallon jug, the possibilities comes to like this: 0, 1, 2, 3, 4. And Y can be the capacity of 3-gallon jug, 1, 2, 3. Yeah, Y represents the amount of water available in 3-gallon jug. So in that scenario, here 5 ways are possible, X can be, and here Y can be 4 ways are possible. Then the total possible number of ways, 5 into 4 is equals to 20 possible ways. In 20 ways, you can represent X comma Y. So the different ways of representing XY is nothing but a problem state. Yeah, the statement is true. The total number of ways can be equals to 20. All possible states in the state space. And coming to D, the problem is solvable because GCD of 4, 3 divides the target quantity 2. Yeah, GCD of 4, 3. What is this? GCD of 4 comma 3, that's nothing but 1. 1 divides the target, 1 divides the target, that is 2 gallons. So definitely it is possible because the capacity is 4 na. one capacity of the second jug or small jug is 3. So the GCD comes to 1. This one definitely targets the divides the targeted value 2. So the problem is solvable. The statement is true. And DFS without cycle checking is guaranteed to terminate a solution. Here we are not going like a DFS solution. Let's say I'm taking depth wise like this, filling 4 gallon jug, making empty, filling 4 gallon, again empty, filling 4 gallon. That means this process will never ends, right? So DFS does not guarantees the solution. The last statement, something like statement F, this is not true, my dear. Whereas coming to A, B, C, D, E, all these statements can be true. This is another possible MSQ question, right? And go through admissible concept. And in this question, you simply fall into the trap just like previous year gate question, but there is some modification. Be careful, be careful. Go through the question. H1 of n and H2 of n are two admissible heuristics. They are these two are admissible heuristic functions. So the search problem, that is for all n nodes, what happen is H1 of n is less than or equal to H star of n. H1 of n, the heuristic value of node n is less than or equals to H star of node n. What is H star refers to? H star is the true cost from the current node n to the required goal node, right? Yeah, you can simply say actual cost from the current state to the goal state. And H2 of n is also admissible. H2 of n is also admissible for all values of n in the state space. So in that scenario, which of the following are true? My dear, when you are counting H1 of n, H2 of n, it should be like equals to H of n is equals to H1, their addition. That cannot be admissible. We cannot confirm that. Let us suppose H star of n is equals to 10 units. Now in that scenario, let us take H1 of n is equals to 8 and H2 of n is equals to 9. Yeah, definitely it is possible. Like if you take H1 plus H2, the answer comes to 17 it is, and it is more than 17 less than or equals to 10. The statement is false here. So you can say this is not at all admissible. And multiplication is very greater value, just like 72, it is also not admissible. But coming to option C, I can take some value in this way. Here I am discussing about option C. Let H1 of n is equals to some 8. Let me keep some 8. And H2 of n is equals to some 0.5. 0.5. If I take 0.5 like this, if you go for H1 by H2, it will become 8 by 1 by 2. It becomes some 16 like. So in that case, it is not at all admissible. So yeah, difference, even when you are taking difference, my dear, modulus should be here. There should be modulus of H1 of n and H2 of n. Definitely, I hope you can notice D is correct answer. Difference definitely admissible. but you have to make one more note that even if you have a functions like maximum and minimum also, in that case also it is admissible, right? Let me use the first example. I am taking first example here. Coming to option E, if I take h1 of n is equals to, same example, h1 of n is equals to 8 and h2 of n is equals to 9, if I go for, then max comes to 9 and 9 is less than or equals to the actual value 10. It is admissible now. Yeah, E can be true. I hope you know that option D can be true, but my intention is you notice max function, min functions, they can also be admissible. So D and E are correct answers. Let's move. Yeah, go through this question. Consider the state space where the current state number is 1. Yeah, let's take the current state number is 1 here, and we can generate the successor functions n plus 1 and n plus 2. You may watch the questions like n plus 1 and n plus 3, but my question n plus 2, my question is different. N plus 1 and n plus 3 I am asking here. Yes, the successor function for node n is, it comes to n plus 1 and n plus 3 here, right? Now, in that scenario, assume that the states which are available in unexpanded list are expanded in the ascending order of the numbers, and previously expanded states are not added to the list. Okay. Once if the nodes are already expanded, then you should not add it to unexpanded list, right? So unexpanded, right? Open list, closed list. In that way, let us take. Now here 1 is available. For this one, expansion comes to 1 and 3 here. N plus 1 and n plus 3, it comes to 4. Next, I can go for exploration of node 1. Node 1 is expanded. Exploration of node 2. So I can take n plus 2, n plus 1 and n plus 3. N plus 1, this is 3 here. And next it comes to, what do you say, 2 plus 3, that comes 5. Then exploration takes place. Exploration takes place according to the ascending order of the numbers. And also we should go for something called BFS approach. Node 2 expansion is over, but in this level node 4 is available. Let us expand node 4 here. So if I go for exploration of node 4, 4 plus 1, that is 5 comes here, and 4 plus 3, 7 comes here. Okay, and coming to this level, and exploration of 3, 3 plus 1, 4, 3 plus 3, 6. Here I got this. Now, in the unexpanded list, in this node, we have 5, 7. I want to expand 5 next. 5 plus 1, that is 6. And 5 plus 3, that is 8. I don't explore this node because 5 is already expanded. And let us go for expansion of 7. 7 plus 1, 8. And 3, that is 10 here. Now, level 0 is completed, level 1 completed, level 2 completed. I am coming to level 3. I am going BFS search, right? If I go for exploration of 4, 4 plus 1, 5, and 4 plus 3 is 7. Now I am going to the exploration of node 6. I can understand now this is the goal node. This is the required goal node. So 1, 2, 3, 4, 5, 6, my dear, 6. After six expansions, don't take this one because this is node 4. Node 4 is already expanded. I don't go to this area. Yeah, 1, 2, 3, 4, 5, 6. After 6 nodes of exploration, I found the goal node by using BFS. The required goal node 6 found after 6 explorations. Okay then. Then let us take a DFS approach. If we go for DFS, 1 here, 1 plus 1, root node is 1 now, 1 plus 1, 2 here, and 1 plus 3, that is 4 here. And let us expand 2. So if you take 2 here, 2 plus 1, 3, 2 plus 3, that is 5. And let expand 3, 3 plus 1, 4, and 3 plus 3, 6. Let's expand 4, 4 plus 1, 5, and 5 plus 1, 5 plus 3, 8. Sorry, 4 plus 3, 7. Next 5 expansion. 5 plus 1, 6 here, and 5 plus 3, 8 here. My dear, what I did here? If you see this, 1, 2, 3, 4, 5. Here I found the goal node after 5 expansions only. When I go for the next expansion 6, I can understand this is the required goal node. Yes, in DFS, the goal node, the required goal node 6 is found. 6 is found after 5 expansions. After 5 expansions. So in 25 gate, they given some question. They will get equal expansions. In our test series also, I have given some question where BFS gets more expansions. But this is the question. Here we are getting DFS is giving, BFS is getting more expansions than DFS. So yeah, like this. BFS expands more states than DFS. In test series, I given some other question, that is DFS gives more expansions. But in this particular question, DFS only 5 expansions. After 5 expansions, we found the goal node. Okay, my dear, now let us go for this question, go through this. Which of the following statements regarding these A star search algorithm or our search algorithms, not only like A star, any uninformed or informed searches. So which criteria is true? A search algorithm is complete if it is guaranteed to find a solution whenever one exists. Yeah, an algorithm that is complete is also necessarily optimal, right? BFS is complete and optimal when step costs are equal, right? And DFS has lower space complexity than BFS, when it is complete in infinite state space, but it is not complete in infinite state space. Okay, fine. So it's not infinite in the sense finite it is. And time complexity of search algorithm depends only on branching factor. Okay. And coming to F, systematicness ensures that the same state is not expanded more than once, right? When you are taking systematicness, it should ensure that the same state is not expanded more than once. Yeah. My dear, just to see these statements, the first statement is if it is the algorithm is complete, we can say completeness. Definitely, if one of the solution exists, it can find that solution. I can say the statement A is true. And algorithm that is complete necessarily optimal. But coming to the area of optimal, optimal refers to the best solution, right? So if it is complete, we cannot say that it's optimal, right? Yeah, there is a statement B. If you write a converse statement to this, I agree it's true. But if you take as it is statement, the algorithm is complete in the sense, if it is complete in the sense, every complete search algorithm is definitely optimal. I cannot agree this statement. This statement is false because let us take DFS, depth first search, and let us consider it is infinite state. So if it is infinite state, let's say this is the root node and some goal node is available here, and the problem is infinite space. I am moving like this depth wise, I will never come back, and it moves on like this, never coming to back. It is infinite state space. So in that case, how you can say the goal node is not found? Let us say if it is something like a finite state, it's a finite game tree. If it is a finite game tree, then backtracking process exists, and here I can come back and I can find the goal node. Yeah, but is it the right way of finding the solution? Is it best way? It is not a best way, but the algorithm is complete. It is complete, but it is not optimal. This is one counter example for option B. So you can say the statement B is false. It is not at all correct. Coming to C, breadth first search is complete and optimal when all step costs are equal. Yeah, BFS is complete and also optimal. Definitely BFS, if step costs are same, when you are going for level by level, definitely you can find the goal node at level D, right? Option C is correct. And depth first search has lower space complexity than BFS because it is not complete, but is not complete in infinite state space. Yes, my dear, you are. It's really true. If the given problem consists a goal, when you are coming to the space complexity, DFS follows some technique. Just like last in first out, it can come. Just like list data structures you can use. So yeah, stack data structure. In that stack data structure, what happened? Currently existing nodes are available. When you are expanding the topmost node, you can remove it, right? You can remove it after expansion. You can remove the node and you will push into the closer list. Definitely it requires less memory. Yeah, you can say order of something like B into D, lower space, order of B into D, where B refers to branching factor and D refers to something called depth of the game tree where the goal node is available. But in case of BFS, I should take order of B power D, right? If B is the branching factor and D is the depth of the goal node, it comes to order of B power D. So definitely it requires a lower space. The statement is true, no doubt. And if the given problem is infinite space, DFS is not complete. You cannot find the solution. That point I already discussed earlier. And time complexity of search algorithm depends on only branching factor. No, my dear, it is not at all. It depends on the branching factor. Yes, branching factor is one important criteria, and also depth of the goal node, depth of the, you can say, level where the goal node is available, and also what is the maximum depth of the total game tree. All these factors will come into consideration. Don't say simply it depends only on branching factor. That statement is not true. And systematicness refers to, it is the ensures that the same state is not expanded more than, yeah, each and every state should expand at most once. Yes, it's a true statement. Yes, we can say the statements like A, C, D, and F are true. Okay, then let us go through this question. Find the most effective path to find A star search. Initial state is A and goal state is J. Yeah, this is the initial state A and then goal state is J. What is the exploration sequence? Can you do this? The exploration sequence and game tree and let's take optimal path. Yeah, initially the root node is A here. First we are expanding something like node A, right? They can give you different possible exploration sequences by observing the nodes, right? From A you can expand B and F. Yeah, from A we can go through B here and also F here. What is the cost function of B? B is just like 6 plus 8 and it is 14 of cost. And F comes to 3 plus 6, that is 9. Then the next exploration comes to F here, and after F can be expanded to G and H. G here and H here. And what about Z? 3, 1, 4 and 9. And comes to H. 10 plus 3, that is 13. Now the nodes which are ready for exploration is B, G, H. G cost is 9 units. So let us explore G next. If I go for exploration of G, I can get I here. What about I? 4, 7 and 8. Yeah, 4, 7 and 8. And the next exploring is going to be I. Next, what you can get? I. From I, you can go for exploration of E, J, H. E, J, H here. What about E? E is just like 4, 7, 12, 12 plus 3, 15. And comes to J, 4, 7 and 10. That's it. And comes to H, 3, 10. Yes, 3, 10, 10 plus 3, 13. Yeah, 13. Now, in the unexpanded list, the nodes what we have is B of 14, E of 15, J of 10, H of 13, which is the child of I, and H of F, H of 13, which is the child of F. Luckily, among all these nodes, the node which consists minimum score, that is J only. Let us explore J next, right? So let us explore J. When we explore J, we can understand that J is the required goal node, isn't it? So the path comes to A to F, F to G, G to I to J. Then the required optimal path is A to F, F to Z, Z to I to J. So the speciality of the problem is the sequence of exploration and the optimal path both comes in same way, but it does not happen in all cases. That is the point we should make it of. My dear, A star search is very important. If they give more duplicate weights, more optimal paths we can exist. Yeah, optimal path cost is unique, but optimal path is not unique. You can find many also. Yeah, let us go for this resolution clause. Go through this problem. My dear, if you see the statement, the resolution clause is just like this. PRR, QR, not R, from this, definitely we can derive PRQ, isn't it? Either P true or R true, either Q true or not R true, then what must be true? PRQ must be true. It is rule of resolution, isn't it? Yeah, the statement 1 is true. But converse statement PRQ is not true always. Let us take P is true here and Q is false here. If I take P is true here, Q is false here, this area false. Let us consider not R is false and R is true. Then finally what happens? This consequence area, this will become false. False or false na? Totally false it is. So this is not at all logically valid. Whereas C and D are okay. So if you ask me which of the following statement is false, my answer is B. B is false and remaining statements are true. Okay. And see this first order predicate logic. In this first order predicate logic, what they are saying here, just to go through it. If Z divides X, the Z is equals to X or Z is equals to 1. So Z divides X means Z is a factor. That factor can be 1 or itself. So simply they are conveying that this X is, this Z is, yeah, X is a prime number. Z divides X. X is a positive integer and Z is a factor. Yes, X is a prime number, this area. And coming to this area, W, Z divides W, and W is also prime number. What is this W speciality? W is greater than X. So in simple words, what you can say, if X is a prime number, there exists, not X here, Z, for all Z, Z divides X. Uh, yes, fine, correct. If X is a prime number, there exists one more prime number W. That W is also a prime number. So in that cases, then which of these statements can make these statements can be true? The given formula phi can be true. In the case of S2 and S3, no problem. But coming to S1, it is a finite set. In case of S1, if you say X is equals to some prime number 7, I can say one more prime number 11 like. In that case, if you say one prime number just like 47, I can say one more prime number just like 57, 59, something like, right? But if I go for X is equals to some prime number, in 90s, I have one prime number just like 97. Next prime number W should be something like some 101 or 103. But X is equals to 97. When I put X is equals to 97, this area is true actually. When X is equals to 97, this area is true. But this area becomes false. So the given predicate formula can be true for S2, S3, but not S1. So you can confirm the answer like this, S2 and S3, which can satisfy means S2 and S3. My dear students, like this we can discuss many questions in this way. I just touched and I just shown the flavor of some possible questions. So you practice more and more, and practice more questions from predicate logic. And also in first unit, uninformed searches, informed searches, don't leave any area, particularly time complexities, space complexities, everything. So yeah, practice well. Wish you all good luck. Thank you.